This video is for Knowledge Organiser 7 for your 7Theta classes. What I would like you to do is read the Knowledge Organiser and watch this video to work through the example and information given to you in the first side of the Knowledge Organiser. I'd then like you to try the questions from the second side of the Knowledge Organiser. Then complete any work set by your class teacher on Maths Watch. So, this Knowledge Organiser focuses on properties of quadrilaterals. These are all information here that you need to know to help you identify the names of different types of quadrilaterals and their properties. So I'm going to just talk you through each shape and their properties. So if we have a look here, this is a square. A square has 4 equal sides. That means that all of the sides are the same length and all of their angles is always 90 degrees. A square has 4 lines of symmetry. That means that if I used a mirror to reflect that, you would find 4 lines of symmetry across it. It also has a rotational symmetry of 4. That means that if I put a pen in the middle of my square and I turned that, and I'll try and show you that using this here, the square would fit into itself 1, 2, 3 and 4 times before we go back to the center. A rectangle has 2 pairs of equal sides. These are opposite, and that means these ones are the same length. We have 4 right angles and we have 2 lines of symmetry. Those lines of symmetry go across like this. Notice there isn't a diagonal line of symmetry for a rectangle. And again, rotational order, if you put your pen in the middle and you turn the piece of paper, it would fit in, and I'll try and do this for you now, once and then twice. A trapezium has 1 pair of parallel sides, the top and the bottom. It's got a rotational symmetry of 1 because as I turn it round, it only fits back into itself when it gets back to the end or back to the beginning. There is no lines of symmetry in a trapezium, and the angles are not necessarily equal. Your trapezium as well doesn't always have to look like this shape here. A rhombus is like a square version of a parallelogram. All of the sides are the same. It has 2 pairs of equal angles. These are the opposite angles here. And we have 2 lines of symmetry. Those 2 lines of symmetry are diagonal, like this. And again, we have a rotational order of symmetry of 2, which means that if I put my pen in the middle, if I turn it a half term, it fits in once. And then when I get back to the beginning at the end of a full term, it fits in its second time. A parallelogram has 2 pairs of equal sides, similar to a rectangle. These are the opposite sides, and it has 2 pairs of equal angles, similar to our rhombus. These are opposite here and opposite here. It has no lines of symmetry. If we were to put a mirror line in diagonally, it would not fit. It also has a rotational order of symmetry of 2, because if I put my pen in the middle and I turn this, it fits in once, and then, you'll have to forgive me for this, once, and then it fits in again twice. I'll just straighten my camera up there. A kite has 2 pairs of equal sides. These are these here and these here. Notice they're not necessarily opposite, they are adjacent. Adjacent means next to each other. It has 1 pair of equal angles, and that is these angles that can be found here, and they're not always opposite each other. It has 1 line of symmetry which goes straight down the middle and intersects it into 2 triangles, and it also has a rotational order of symmetry 1, because if I put my pen in the middle and I turned it, it wouldn't fit in until it went back into itself or after a full turn. Again, a kite can look like an arrowhead, and it can look in different ways than what this diagram here typically looks like. I'd like you to use these properties to complete the questions on page 2 of your Knowledge Organiser, and then the work set by your class teacher on MathsWatch. Thank you.